Okay, precision and accuracy. These terms are sort of similar, and yet they are distinct from each other. Accuracy is referring to how close the measured value is to the actual value, and precision refers to how close a series of measurements are to each other, or how reproducible they are. I think I've got a picture coming up here. Oops. Well, there's that one. I was thinking more of the bullseye one. So I'll draw a picture. So we can think of this in terms of like a bow and arrow or darts or something where you're aiming at a target. And good accuracy means that you're going to hit the bullseye. It's accurate. Okay? Precision means that the arrows go real close together. Not necessarily that they're hitting the bullseye, but maybe they all hit over here, but they're just all right on top of each other.
So consistency.
Consistency, yeah. Precision and consistency are pretty much the same thing. So you can have accuracy without precision. You can have precision without accuracy. Of course, you could have neither, or ideally you'll have both. When we know what the true value is, then we can tell how accurate something is. But sometimes, we're measuring something for the first time. We don't know what the true value is. And so precision suggests that things are going well, but that's not always the case. So let's look at these students and their data. So they took a lead block, and the mass of that lead block is known to be 100.00 grams. And they each weighed the block 4 times, and these are their results. So they made 4 different mass measurements of the same object, and then they averaged them. Just looking at this table of numbers, it's a little hard to make sense of what all this is. Scientists use tables of numbers like this so that we can concisely show data, but then oftentimes a graph is more helpful, makes it more visual. So here's student A. The first my pointer's being weird. The first one was 10.49, and then, yeah, I'm not even pointing and it's still there. The next one was 9.79 and 9.92 and 10.31. So you can see that these, the heights of these different bars are all over the place. That is poor precision, right? Very scattered. How do we determine if they're accurate? We have to look at the average. Because you could have your arrows going all over the place, but when you average them, they average to the center of the bullseye. So the average here is the blue line. No, I'm sorry, it's the dotted line. The blue line is the true value. So the average of these is above, and fairly significantly above. So student A was inaccurate and imprecise. Probably not going to pass the class. Student B, the values agree nicely with each other. They are precise, consistent. But when we look at the average, it's significantly lower. So this student is doing something that's causing all their values to be low. They're consistent about it, but they're inaccurate. Okay? This student has good accuracy and good precision. The values agree closely with each other, and the average is very close to the true value. Okay? This is what we always want to have. Any questions? Sounds like a war zone out there. So what can cause inaccuracy or imprecision? Random error is a type of error that leads to values not being very precise. Random error is an error that has equal probability of causing your value to be too high or too low. If we take a bunch of measurements where there's significant random error and we average them, because the error is random, we can expect that the ones that went too high kind of cancel out the ones that went too low. And that's why we frequently make 3, 4, or even 5 duplicate well, they're not duplicate, repeated measurements, because we get better accuracy that way. The random error, which many times cannot be controlled, it's just going to be there, we can get rid of that by averaging. So systematic error is an error that is always going to be too high or always going to be too low. And this usually has to do with an error in how the user is using the measuring device. If you're using a ruler and you're measuring from the end of the ruler instead of from 0, all your measurements are going to be off in the same direction. If your balance is not calibrated correctly, then your measurements are all going to be off in the same direction. This is the sort of error that we should be able to correct for, that we should be able to find and fix. But you can get very precise results and you're like, oh man, this is really good, I'm doing really well, but your answer might be significantly off. Any questions about that? Random error and systematic error.